All right, so sideboard again over here. SWBA students will be able to review the order of operations. Okay, you guys have learned this before, right? Order of operations. What do you guys know it as? Maybe another word that starts with a P. Pentas. Okay. You guys might have heard something about ant too, right? Please excuse
my dear
Aunt Sally, right? And it's to help us remember the letters PEMDAS. Now, what's the P stand for, everyone? Parentheses. What's the E stand for? Exponents. M. Multiplication. D. Division. A. Adding and subtracting. Okay. So a lot of times when we see this, there's actually a misconception here that we think there's 6 steps, but actually there's 4. Because there's 6 letters, we think, oh, we have 6 steps, but it's not true. There's actually 4 steps, and we'll talk about that a little bit here. Okay. So our first step is to evaluate the expressions inside grouping symbols. Inside grouping symbols. Symbols used to group. Okay, grouping symbols. And you can see there's a little asterisk there, and it goes down to here. Grouping symbols include. Can anyone think of a type of grouping symbols? One even starts with that P there. Okay, Emily. Parentheses, right? Those are the most common ones we see. Okay, there's actually going to be 4 types we're going to talk about, but those are the most common ones. Lainey.
The one that goes like that.
Yep, the one that goes like this is a bracket. It's like a much harder or blockier style parentheses called a bracket. Okay. What about another one? Okay, Emily.
Isn't it brace?
Very good, brace. Yeah. So braces, like what you wear on the teeth. Okay, are the squiggly line version. Okay, it's very squiggly. Okay, people sometimes think, oh, the squiggly one. Okay, braces. Okay, and the last one we'll talk about is actually the absolute value symbol. Okay, we don't use those just typically to group things. It's a very special occasion, right? Absolute value, because it's the distance from 0 is always positive. Okay, but it also acts as a grouping symbol to where we would do that before we do anything else. Okay, so if there is more than one grouping symbol, because sometimes you have multiple, some inside of another, you start with the innermost grouping symbol. Okay, you work inside out. Step 2, we evaluate all exponents. So that's the E in PEMDAS. Okay, you evaluate all exponents. Okay, so that's when you do all your powers after you're done with the grouping symbols. Then step 3 is you multiply, and or divide in order from left to right. So you multiply and or divide in order from left to right. So this is where the big misconception comes. A lot of people tend to think that you multiply all the way through and then you divide all the way through. That's not true. You do multiplication as you see it left to right. So if you see division right away, you do division first. Okay? If you see multiplication right away, you do that multiplication first. Okay? When you get to this step, you do it at the same time. You guys ever seen on social media those problems where like they see like there's an order of operations math expression, and it's like, what do you get? What do you get as your answer? And like people in the comments are getting all sorts of different answers and arguing about it. Like, no, it's this. No, it's this. You guys know what I'm talking about? Okay.
Yeah.
Okay. So that is usually because of this step right here. Okay. Almost always it's because of that step right there. Okay.
My husband argued with me about one of those.
Yeah.
Argued. I said, you didn't do PEMDAS. He goes, what is that?
Yep. Yeah, a lot of people get that wrong because of this one step right here. They think, oh, like I see multiplication, then I do division. I'm like, not true, same time. Now, like I was at a wedding a few weeks ago, and while I was at the wedding, I was sitting at the table. And one of the people at the table were like, oh, you're a math teacher. I'm like, yeah. And like, okay, so I had this problem, like my brother brought home, and like I want to know what the answer is because we were all arguing over it and we couldn't settle on it. And so he pulled out the problem. And it's like, some of us got 16, some of us got 1, and like, and it all comes down to, you had to divide before you multiplied in that problem because you saw it first. And so people just tend not to think that way. And so it was just supposed to be a tricky problem because of that. But anyway, so that's, that was that problem. So then step 4 is going to be, you add and or subtract. You add and or subtract in order from left to right, okay? So those last two steps combine two letters, okay? Those last two steps each combine two letters, okay? So multiply and divide, same step. Adding, subtracting, same step. Questions on that? Tanked open Liddy! Okay, evaluate each expression. Okay, so 48 divided by 2 cubed times 3 plus 5. 48 divided by 2 cubed times 3 plus 5, okay? So does anyone know what we would do first here? Okay, Tucker.
We would do the exponent, which is 2 cubed.
We would do the exponent 2 cubed, okay? So then we ask ourselves, okay, what is 2 cubed? Okay, does anyone know? Okay, what do you think, Eleni?
8.
It is 8, okay? Now, if we don't know that, what we could do is off to the side, you can say, okay, 2 cubed means there's 3 2's being multiplied together. So I can say, what's 2 times 2? 4. And what's 4 times 2? Well, that's 8. Okay, 4 times 2 is 8. Okay. Another way that people like to write this sometimes is saying, okay, 2 to the first is 2, 2 squared, 2 times 2 is 4. Or I said 4, then I wrote 2. 2 times 2 is 4, times another 2 is 8. So that's 1, 2, 2 2's, 3 2's, the squared, and then the cubed. Okay? So now in our next step, we're going to rewrite everything the same, except for 2 cubed is just replaced by 8. So now we have 48 divided by 8 times 3 plus 5. 48 divided by 8 times 3 plus 5. So what would come next? What do we do next here? Okay, Maddie. 48 divided by 8. Very good. Multiplication and division, left to right. So we see division first. So what is 48 divided by 8? Does anyone happen to know, Maddie? 6. Very good. Okay. So 6 times 3 plus 5. Okay, 6 times 3 plus 5. Okay. If you have trouble with 48 divided by 8, you could also say, how many times does 8 go into 48 to help you out? Okay, Lynn, can you take your butt out, please? Okay, thank you. So now, what would we do next here? What comes next? Mason, what would you do next? Multiply. And what's 6 times 3? 18. Awesome. Now we have 18 plus 5. And Olivia, what is 18 plus 5? 23. Very good. Right on the money. So that'd be our answer here, okay? It's 23. Okay? So this would be one of those problems you see on Facebook that would try and trick people. Okay? Have you guys ever heard these called a funnel problem before?
Yeah.
Okay. I know some of you guys have heard that, maybe some of you guys haven't. Where it kind of looks like a funnel like this, kind of narrowing down a little bit more as it goes into it. Now what I want you guys to do is on number 2, I want you to try number 2 on your own. And if you have questions, or you have it right, or think you have it right, raise your hand, okay? So if you have it, think you have it, or have questions, raise your hand, okay? And this has one, I will come around and tell you whether or not you got it right or not.
You know how when you know you did it and you know it's not right?
Yep. Very good. You got it right. Raise your hand if you have not been checked yet. Raise your hand if you have not been checked yet.
I'm not done yet.
What? It's not on. So I said, that's flashing. It's on me, yeah. Yeah, I mean, we're all talking to other students. Yeah. So,
Try 1, 5, 7.
Huh?
Did you get it?
Got it.
Try to do the other check.
Yeah, but,
Did you fix it? Sylvia, did you get your check?
so let's put it times, so 5 times 3. Sorry, we had the parentheses here, didn't we? We're just kind of copying out what we have, but each thing getting small. Making it small at a time. Then we go to the next one, that's 5. We have 3, that's 5, okay, that sounds good, David? Yep. Let's talk about this one up here, okay? So on number 2, what would we do first here? Reagan, what did you do first? 8 minus 3, it's in parentheses, right? Okay, now we can actually do what's inside this parenthesis at the same time, okay? They're separate parentheses, so we can do them at the same time if we like. We don't have to, but you can, okay? So what would be 3 plus 2 over here?
5.
It would be 5, okay? So we have 5 times 3, and then this 5 in parentheses. Now what's it mean when there's a number next to a parenthesis? Multiplication, right? So we have multiplication, multiplication. Which should we do first? The 5 times 3 on the left, right? So what is 5 times 3? 15. So we have 15 times 5. Now you might not know this off the top of your head, and that's okay, okay? Because we can write it over here. 15 times 5. How many times does 5 go into 5? 20. 25, so you put the 2 above the 1, 5 below. What's 5 times 1? 5 plus 2? 7. So we have 75 as our answer. Any questions on that one? Alrighty, okay, so let's move on to number 3. Hey, tricky thing on number 3, guys, just so you know. This right here inside the bracket, that is a 12. Some people see that and it looks like a 1, or it looks like a 2, excuse me, because that 1 right next to the bracket, but that's 12, okay? So it's 12 divided, okay? 12, not 2. Okay. So let's go ahead and work on number 3. you're done and want to move on to number 4, you can. If you're done and want to work on number 4, then you can.
Okay, so. I'm going from the.
Yes,
this
I'm
first.
just like I have been. Twelve. Have you done anything with that? This is gonna stay. Have you done this division yet? Yes, it's gonna stay. You use this here too. Okay, what is that? Four more. Have you done this bracket yet? Yeah, keep that. Have you done the second one yet? Keep that. Does that make sense? You look at this. What comes first in all of this? Very good. So it's brackets. So let's 12 divided by 4.
Very. Nine. Four times nine.
You're doing 3 times 2. 3 squared is 3 times 3. 24.
Thank you.
Thirty-six.
Oh, yeah.
Yeah.
So let's actually subtract. Oh, you subtract the top, subtract the bottom. Is that your question? What division are you doing? Yep. So you do the whole top, the whole bottom, and then afterwards, So let's talk about number 3 on here. Thank you, Reagan. So 4 times the quantity of 12 divided by 6 minus 2, all being squared. So what comes first here? The very most innermost parenthesis, right? So we do the 6 minus 2. So we still have this 4 here. We still have this bracket. We still have this 12. We still have to divide. 6 minus 4 though, or 6 minus 2, excuse me, is 4. And we still have that squared, okay? So now after that step, what would come next? Well, we still have more grouping symbols, right, Maddie? What would we do? The brackets, and what's 12 divided by 4? 3, so now we have 4, we still have the bracket with 3, and the squared, okay? So it's 4 times 3, remember this is times, and being squared. So 4 times 3 being squared. So what would we do next, multiplication or the exponent? Exponent. So what is 3 squared? And don't forget, 3 squared does not mean 3 times 2. 3 squared means 3 times 3, so it is 9. So what's 4 times 9 now? 36. So our answer is 36. Okay, questions on that one? Alrighty, okay. So if you haven't already, go ahead and move on to number 4 here, okay? And if you have questions, or think you have it, go ahead and raise your hand, okay? So if you have questions or think you have it, go ahead and raise your hand. And let me say one quick thing about this, because it's kind of confusing actually, because it's pretty poorly written actually. So this should be 2 to the 5th minus 6 times 2 over 3 to the 3rd minus 5 times 3 minus 2, okay? So let's make sure we have those subtraction and multiplication symbols there, because that can trip us up, okay? I promise you I'll come back for a moment.
What about the top of the box? Where? There's two of them. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16.
Double.
8 times 2 is oh, that was 2. 36. Okay, so what's 6 times 2? 36 minus 12.
Yeah.
And then the bottom, same story. So you do 3 to the 3rd, which is like an 8. So now what is the
Top number is 20, and bottom number is 10. So that was
What if we do verse That's how many we can make it. Okay.
No, I did something wrong. Oh, no, I didn't.
Oh.
I'm messed up. I meant to put it up here.
Think about this. You have 2 times 2 times 2 times 2, you get 5 twos, right? So 2 to the 5th, you get 5 twos. So what's 2 times 2?
8.
2 times 2 is 4. 4. Okay, so I use 2. Now I have another 2. What's 4 times 2?
8.
Okay. Okay, what's 8 times my 4th 2?
16.
Okay, so now I have my last 2 in. 16 times 2. And then that is 2 to the 5th. Okay.
I feel what if I just.
Elbow.
You're like. I'm so sorry. Did you hear what I just said? I don't know, it just kind of like came out.
Cause like,
Have you
I
ever
was
been
a
called
girl
a
at
witch?
first and all that.
That you want to be away?
I had it, and then not because I got
You do?
school, and I was like,
No, not.
it's worship.
So we're the opposite of that.
So let's talk about this one, okay? I know you might not be done yet, that's okay.
Not.
So, what would come first on the top? I know we didn't talk about this, but with a fraction, we do the whole numerator at the top of the fraction, and we do the whole denominator bottom of the fraction, and then we divide at the very end, okay? We divide and simplify at the very end if we can. So on the top here, 2 to the 5th minus 6 times 2, what comes first? Okay, Tucker. I think you mean exponent, right? Yeah, we've been talking about exponents and expressions, okay? And the exponent. Now, 2 to the 5th. You might not know 2 to the 5th off the top of your head, okay? So one thing I was telling people to do is kind of this little finger trick, okay? Where you start with 2, that's 1, 2. 2 times 2, that's 4. Add another 2 in there. That's times 2 again is 8. Add another 2 in there. 8 times 2 is 16. Times another 2, that is 32, okay? So this ends up being 32 minus 6 times 2 on the top, okay? Another way to think about this, guys, is to write them all out at once. 2 times 2 times 2 times 2 times 2. Is that 5 of them?
Yeah.
Good, that's what it should be, 2 to the 5th. That means 5 of those, okay? So then you can say, what's 2 times 2? 4. What's, oh,
You're good.
I'm sorry, Reagan. Did you catch that all though, or no?
Yeah.
Okay. What is 2 times 2 over here? Well, 4 again. And then this last 2 I'm going to bring down with me. So now it's 4 times 4? 16. What is 16 times 2?
32.
32. So notice we end up with the same thing, right? Okay. So those are both just different kind of styles of doing it, okay? Is you can just continue going up by 1 more multiplication each time, or you can kind of batch them together like this, okay? Now, down here on the bottom, 3 to the 3rd minus 5 times 3 minus 2. What comes first out of that, Mason?
The exponent.
The exponent. What is 3 to the 3rd?
9.
Nope, not quite. 3 squared is 9. Okay? Not quite. So, Emily, what did you do?
3 times 3
Yep, and you got 27. So 3 to the third is 27. So 3 times 3 is 9. 9 times 3 is 27, okay? Then we have 27 minus 5 times 3 minus 2, okay? On the top here, 32 minus 6 times 2. What would come first, subtraction or multiplication on the top? Multiplication. What is 6 times 2, Abby? 12. It is 12. So we have 32 minus 12 on the top. Okay, 32 minus 12 on the top. On the bottom, 27 minus 5 times 3 minus 2. So what operation is going to come first there, Olivia?
You would have to subtract the
It's not quite. So when there's subtraction, multiplication, and subtraction, what would you do first? Or in the order of operations.
Olivia, did you write PEMDAS on there somewhere? You did? What did you, what question did you ask? Oh,
What do we,
27. What would we do next with 27 minus 5 times 3 times 2?
you would multiply the 5 and 3. Very good. Okay. So you have 27 minus 15 minus 2. 27 minus 15 minus 2. Okay. That 15 kind of came out looking more like a 45. Okay. And then on the top, so 27 minus 15 minus 2. On the top, what's 32 minus 12? Lainey? 20. We only have one operation left there, right? So it's 20. On the bottom, doesn't matter what we subtract first. Okay, Tucker's saying yes. Tucker, what would you subtract first?
Left or right?
Left to right. What's 27 minus 15?
12.
12. So we have 12 minus 2. So then what is 12 minus 2, Reagan? 10. So we have 20 divided by 10. Okay? Let's look at what would have happened if we didn't do left to right. Let's say we wanted to do 15 minus 2 first. We thought maybe that's easier. Okay? Let's take a look real quick at seeing what that would have happened. We aren't quite done yet. Let's take a look and see what would have happened. So if we were at the same step as earlier, and we had 32 minus 12 over 27 over 20 over 27 minus 15 minus 2, and we said, okay, top's still going to be 20, while on the bottom I want to do 15 minus 2 and get 13. Well then in my next step, what's 27 minus 13? What would 27 minus 13 be?
14.
Yeah, it would be 14. 27 minus 13, 7 minus 3 is 4, 2 minus 1 is 1. So it ends up being 14, okay? Is that the same thing? No, that means this way was wrong. Tucker was right. It did matter which way we did it, and we had to do it left to right, okay? Now, is that true for addition? Do we have to do addition left to right? No, addition actually can be done in any order. We have a property that says that it doesn't matter whether we do 3 plus 2 plus 1, means we get 3 plus 2 is 5, plus 1 is 6, or if we do the reverse order on this one, if we did 3 plus 2 plus 1, and we did 2 plus 1 and got 3, 3 plus 3 is still 6. So we can do it in addition, we can move them around. Subtraction, no, we can't, okay? What is 20 divided by 10 though, guys? 2, so we can finish off that fraction as a division problem, okay? Any questions on that? Okay, so we got a little bit more there, we got a little bit more still, okay, to do. right beneath it's called evaluating algebraic expressions. Yes, Aiden. Okay. Do you have your pass?
Yeah.
Okay. Evaluating algebraic expression. So to evaluate an algebraic expression, you replace the variables. As you can see here, now we have variables in this. Okay, with their values. Then find the value of the numerical expression using the order of operations. So the second step is going to be the same as what we've been doing. Second step will be the same as what we've been doing, okay? Real quick typo. This z equals 2, it should be over here, okay? And z equals 2, okay? So z equals 2 should be over there. So go ahead and change that real quick, okay? So that's a quick typo I made, okay? So you guys might have done something like this in Algebra 1A last year, okay, with Mrs. Springer. X times the quantity of y to the third plus 8 divided by 12, okay? X times the quantity of y to the third plus 8 divided by 12, okay? So with this, we're told that x is 3 and y is 4. Does anyone know what we're going to do with that 3? Emily? Plug it into the x spot, okay? What are we going to do with the 4? Plug it into the y. Very good. Can someone help me plug this in? Can somebody tell me what I would write on my next line? Okay, Maddie. Yeah? Yeah? Okay. Very good. Now, you might notice I actually add in a couple extra parentheses here. You might be like, well, that's kind of weird. Okay, I haven't seen that before. I add in extra parentheses because that can help when we have negatives. Okay, it can be really handy when we encounter a lot of negatives. Now, there are no negatives here, so I can actually drop those extra parentheses in the next thing I do. They're necessary. They are not necessary, but they can help solve little mistakes. Okay. Any questions on how Maddie plugged these in? Any questions on how Maddie plugged these in? Okay. Everything's the same in this first expression as it is in the second, except for now instead of x you have 3, instead of 4 you have, or instead of y you have 4. But just like y was being cubed, 4 is now being cubed and then added to 8. Then the whole thing's still being divided by 12. Now, according to order of operations, what would come first here? The exponent. So we would do
wait.
inside parentheses, right?
Yeah.
Yeah. So we go inside the parentheses, then you can figure this one. Yeah. Okay. So inside the parentheses, now we do the exponent. What is 4 to the third? Well, we don't know necessarily. Okay. So what's 4 times 4? 16. Okay. Now 16 times 4. You might have to write this one out. What's 6 times 4? 24. Hey guys, what's funnier than 24? 25. Got a little SpongeBob, okay? So, let me fix that up a bit there, okay? Now, what's 4 times 1? 4, add the 2 to it? 6, so 64, okay? So you have 3 times 64 plus 8 divided by 12. Like I said, we didn't end up having any negatives, so we can drop that extra parenthesis I put on there. Okay, we didn't have any negatives, so I can drop the extra parenthesis we had on there. Now, what would I do next here, though? Okay, Tucker? Yeah, do the original parentheses. What's 64 plus 8? Okay, Reagan?
72.
72, very good. Oh, what just happened?
Oh,
There we go. Yeah, that was weird. Okay, if you had trouble with that one, 64 plus 8, you can write it over to the side. 8 plus 4 is 12. And then 1 plus 6 is 7. Okay? Now 3 times 72. Once again, we might need to write this off to the side. What's 3 times 2? 6. And what's 3 times 7? 91. Okay? So you got 216 divided by 12. Might not know this one either. Okay, 216 divided by 12. We're doing some math. Does 12 go into 2? Does it go into 21? Yeah, how many times?
3 times.
Not 3,
2.
1 time. 1 times 12 is 12. What is 91 minus 12 though? Anyone know? Try again.
96.
It would be 9 and then we would drop down to 6. Okay? And if you're struggling with that 21 minus 12, don't be afraid to write it out. Okay, you have to borrow. 11 minus 2 is 9. And 1 minus 1 is 0. Okay? So now 12 into 96. Whoa, okay, that might be a little bit tough for us. Well, here's a tip, guys. How many, what, 12 times what is 96? That doesn't help. Here's another tip. Okay, we're hoping that this will end in a 6, right? Whatever times 12 will end in a 6, and it will just be this exactly, right? 96. Okay, so what times 2 could end in a 6? What times 2 could end in a 6, Abby? Okay, 3 could. So we could try 3. So we can try, say, hey, 12 times 3, well, that's 6, 3, so 36. Do you think maybe we should go a little bit higher than 96? Okay, let's try another number. Okay, 26 might be a little high, okay? I'll try 6, okay? Well, what's 6 times 2? 12, does that end in a 6 if we want? Okay, but what times 2 might end in a 6?
6.
Okay, nope, we just tried that one. 8, okay, what's 8 times 2? 16, let's try that one, okay? We're hoping this one works out. Now you could have tried it, 6 still. We're trying this other method, okay? So 8 times 2 we said was 16. What's 8 times 1? Plus 1? 9. Hey, did we get what we wanted? Okay, so sometimes if we just try and line the last number, if we know there's not going to be a decimal, or we're hoping there's not going to be a decimal, we can just try the last number there, okay? And try and get that to line up. So it ends up being 18. Okay? Questions on that one? That was a bit of a long one, wasn't it?
Yeah.
Okay, a bit of a long one. Okay, we're gonna set up the second one. We're not gonna solve it. Okay, we're gonna set up the second one, but we're not gonna solve it. So can somebody help me about plug in x, y, and z here? Okay, Lainey, you wanna help me?
2 parentheses, and then 4 squared, minus 3, and then plus 2 squared.
Very good. So what Lainey does, she just took x, replaced with 4, y replaced with 3, and z replaced with 2. Every operation those we're doing, she's just having the number that replaced it do those operations, okay? And once again, I added in those extra parentheses here, okay? Just because I think it helps simplify some little mistakes, okay? Now, if we were doing the full problem, which I'm going to cut short just for sake of time to get some more work time, okay? We would be continuing on doing word operations. We're not going to do that right now. Does that make sense, though? That we would, but we're just trying to save some time at the moment, okay? So I'm going to pass out our homework. I'm going to pass out our homework here.